class as well, and we are coming to treat circuit theorem, which is geometry 2. Diana is here and she's ready for the class. Here is look at her face. So you're about to start. Stay tuned and then share it to friends as well. Thank you. Peace out. Give me a few minutes for me to share it to the group so that you can start. Okay, don't worry. I have to set the camera so that you can see it on the board clearly. Let me mute. Hello. Hello. I'm testing the microphone. We're about to start right now. So I hope you can see the board clearly. So what you do is that if you have any challenge, just comment it in the comment section below so that I will know maybe if you can see the board clearly or not. Today's class it will be really intensive because we will finish the whole menstruation 2. We will finish the whole menstruation 2 today. Not menstruation, sorry. Geometry 2 today, which is called Circle Theorem. I think you can see the board clearly now. You can see it clearly. Let me place the microphone. Hello. Okay, so let's start. Yesterday we treated some topics and we treated 4 properties, right? Yesterday we started with four properties. Wait, okay. I think the light reflects so that I won't be writing there. Let me see. Okay, it's at this side. It reflects this side. So let me draw something here. So I won't be writing there so that you won't. Yes. Not really. I think it's here. It's here somewhere here. The light reflects there, so I won't be writing there. So now we are coming to start menstruation 2, and I'll be guiding you throughout. I will teach you some strategies and some tricks that it will help you to remember the properties. Note that I don't go by the order of laws, properties, maybe property 1, property 2, property 3. And as a matter of fact, I'll be really glad to teach you this one so that you won't suffer to remember everything. So first of all, what you do here is that I will teach you how you can go by it. I'll teach you by how you can go by it. That is how you can solve the questions or get the answers from the question whenever you see the question before we teach the presentation of the answers. So for instance, if you have this question, okay. If you have this question, for instance, and this is the center, and if this is the center O, you will know that based on the let me say one of the properties I taught you yesterday, I told you that whenever you see such questions like this, always 2 times of what the angle here, 2 times of the angle here is equal to the answer. Always 2 times of the angle here is equal to the answer. In other words, if here is x, here will be what? Here will be 2x. So with this one, when you have here at 60 degrees, it means here will be what? 120 degrees. 120 degrees. Here will be 120 degrees. Here will be 120 degrees. I hope it's clear. So this is let me say visual way of solving it. So I want us to learn how to solve it visually. In other words, when you see the question, you'll be able to do something to get the answers. After getting the answer, then I teach you how to present your answers the right way. WAEC accept. WAEC will accept it. Someone is texting me. I'm coming. Someone is in the comment section below. I want to reply something here. if you are watching me, let me know where you are coming from, and then if you are watching me, let me know where you are coming from, and then the school, or if you are in the house, so let me know it. Then please, I'm coming. Okay. Okay. Okay, so let's continue. So as I was saying, this is how you will solve it. This is how you solve it. If this is a visual way to get the answer. So let's move on. Yesterday we learned 441. So I want to do quick revision of it. What properties? So the first one, I said when you have a circle. Oh, I said I won't erase this side. Where the light reflects. Is it this side? This side, somewhere this side, right? I want to see somewhere. Yeah, that side, this side especially. So I won't be writing there because the light reflects there. So let's continue. The first law we spoke about, and then I describe it. The first law, if here is if you have a chord here, and then this is the center, and we said if maybe two or more triangles, the base have the same chord, right? If the base have the same chord, what's the relationship between this and this angle and this angle? They are equal. So we got to realize that when they have the same chord, when the two triangles are on the same chord, you will see that the angle between this triangle, or between this side and then this side, is the same. So if here is x, here is also what? X. If here is 60, here is also what? 60. And then the next one too we talk about is that if you have another property, we have another property whereby if you have a circle here, and then this is the center, and this is the chord, this is the center, and when you draw a triangle, when you draw any triangle, two triangles, whereby they have the same chord, but one touches the circumference, one of the triangle touches the what? The circumference, and then the other triangle doesn't touch the what? Circumference, but it touches the center, right? That one, the relationship there is what? What is the relationship between this angle and then this angle? So now we got to realize that 2 times of the bigger triangle, this triangle, yeah, 2 times of this one. So if here is x, then this angle will be what? 2x. So this is another property we talked about yesterday. And another property that we also talked about is that if you have a circle, with the center here, and then you have two triangles, whereby they are on the diameter, the base is the diameter. So this one, and then this one. So these are two triangles, but the base is what? Diameter. This time the base is not a chord, it's a diameter. And the other side, the vectors of the other side, or let me say where the other side, the two sides of them, apart from this side, the two sides of them are chords. They are chords, and they meet at the circumference. Then we said this angle is called something. What will be this angle? What will be this angle? You forgotten. Ah, then remember, I told you that today I said I will prove to you how the laws came about. You can prove it here. So after that, I'll prove it to you. So now, this one I told you that if you have a diameter and then there are two there are two triangles on it. There are two triangles on it. You got to realize that the triangles that are on this diameter, you see that there will be a angle between these sides, the other two sides. This angle here will be 90 degrees, and then this angle here also will be 90 degrees. In other words, whenever you have two triangles which have the diameter as the base, the angle of the other side, so this is the diameter, so the angle that is opposite to the diameter, so the angle that is what opposite the diameter will be what 90 degrees. Then do you understand? Okay, now then we talk about another property too. For another property, I told you that it's about quadrilateral. It's about what? Quadrilateral. Whenever you have a quadrilateral, you can use that property. So if this is a circle and then this is the center, if this is a circle and then this is the center, you got to realize that if you have a quadrilateral, that it's all vertices. In other words, let me say it's all four corners touches the circumference. It's all four corners touches the what? Circumference. Here you will see that the sum of this side plus this side should give us what? If here is A and here is B, the sum of them should give us what? 180. So A plus B will give us 180. In other words, if even one of the vertices doesn't touch the circumference, you can't use that property. Then do you understand? So always you can use this law only if you have all the vertices touching the what? Circumference of the circle. Is that understandable? Is that understandable? Okay. Let's continue. So I think we are done with this one. So today we are moving to another property. Yesterday I gave you some assignments, right? Right? I gave you some assignments. I want you to come and try it here. Let me see. So with this one, you can try this one. So with this one, for instance, with this question, for instance, if you have a question like this, and then there is if you have question like this and then there's the center and you have here to be a triangle and then here to also be a triangle, here's a triangle and here's also a triangle, we can apply one law to solve this question. This is x and then this is what? 65. This is 65 degrees. This is x. This is O. Here is x. And then the name here is R. Here is what? Q. This is Q. This is P. And this is S. Okay. So you got to realize that with this one, we can use the other law that talked about the one at the two triangles at the center. And yesterday, so I told you that whenever you get a question like this, you have to indicate some chords in it. Sometimes they won't bring the chord. You have to show the chord in it. So based on this question, you will see that there should be a chord here. You can use this chord to get the answer, right? You can use this chord to get the answer. I'm not gonna answer. If here is the center, if here is the center, you assume that the question is like this. So you will turn the paper. They've turned the question, so you turn the paper for you to get the question right. So this one will turn this one, and then you see that there is a triangle from the same chord. This triangle and then this triangle, they are from the same chord. But this one touches the center, and then this one touches the what? The circumference. In other words, you see that if here is 65, you can apply that law. Then the angle here should be 2 times of the angle here, right? So what will be this angle? 130. After getting 130 here, then you use angle at a point. Angle at a point is equal to 360 degrees. Angle at a point is equal to 360 degrees. I mean the total angle. And then you have here as 130. You have here as what? 130. So what will be this angle? You will deduct it from what? 360. Do you understand? So you deduct this one from 3 to be 360 minus 130. That will be the answer. 360 minus 130 is going to get us what? 230. So it means x is equal to 230. This is a visual way of solving circle theorem. Visual way of solving circle theorem. I wanted you to get this one right first before we start presentation. Let's move on to another law. Or let's practice some questions similar to this one first, right? Before we move on to this. So let's try this question. Let's try this question. This is the center. So here to here. Then you have this one here. And then you have this side here. Okay. And then you have been given here as 100 degrees. This side as 100 degrees. This side is 110. 110. So this is here is called, are you drawing the question? This is called, here is V. Here is V. Here is U. W. Z. This is Z. X. Y. So try this question. Let me see. You are asked to calculate I. It said find angle, calculate for angle X, Z, Y. And then they ask you to calculate for angle W, X, Z. W, X, Z. Try it and let me see. Try it and let me see. Alright done. So guys, try this one and let me see. So try this question and let me see if you can able to. You are finding angle x. You are finding angle xy, xzy, and then angle wxz. So try it and let me see. After that, I will explain it how. I just want the answer so you can. If you are watching me here, after getting the answer, you can comment below the answer. You said angle x zy equals, then give me the answer, then angle x wxz. Do you know how to read the angle? Do you know how to read the angle? Okay, I've taught you, right? If you don't know how to also read the angle, you can let me know so that I will help you out with it. So I'm waiting for your answers, guys. Hurry up, hurry up, hurry up. I'm waiting for your answers. When are you done? Hurry up. I'm waiting for your answers, guys. Hurry up, hurry up, hurry up. Comment below your answer. Someone sent me a message here. He said, "Hi, bro. Where are you from?" I'm in Cape Coast. I'm in Cape Coast. I'm in Cape Coast. Yeah, I'm in Cape Coast. So I'm waiting for your answers. Hurry up with the question. So after that, just I'm watching here. I'm waiting for your answers. You just give me maybe say please x angle. Just say angle x zy equals. Then you give me the answer that you got. Then angle wxz equals. Then you give me the answer that you got. Then are you done? I keep it longer. Let me see what you are doing. Okay. So half of one thing, okay, let's solve it. Okay, so let's try this one. Let's try this one out. So this one is very simple question. So see, I told you that sometimes they hide some chords. They hide some chords. So you have to indicate this is a hidden chord. That's when you're able to draw it there. The answers will be clear to you. These are hidden chords. This is one of the hidden chords. Yeah, so when you're able to draw this chord, you'll be able to get the answer at each. So you see that this is a triangle, right? On this chord, this one is a triangle, one triangle. And then this one too is another triangle. Have you seen? This one triangle, and then this one too is another triangle, right? This is also another triangle. So here is one thing. If here is one thing, it means here is what? Half of it, right? And then let's look at something here. This is another from here, which is XOOZ. XOOZ is the bigger triangle, the another triangle I'm talking about. And this is also another triangle. Have you seen? This is also another what? Triangle. So you realize that here will also be what? Half of what? Here, right? Here will also be half of here. So if here is 110, it means the angle here will be the same as what? The angle here. Is it clear? Now the question asks us to find XZY. Where is angle XZY? X, X, Z, Y. So it means the XZY will be what? Half of this one, which is what? 55 degrees. That's all. So it means this one, the answer is 55 degrees. Now let's check up for the other one. WXY, WXZ, no, WXZ rather. So for WXZ, you will see that WXZ. That is the angle here. WXZ, right? Look at here. WXZ. So the angle here. The angle here. For us to get this angle, you see this is a triangle from here to here. That is X being W or W being X. It's a triangle, right? So we know this one. The reason why we know this one is that half of this is a triangle, so half of this one will be here. Have you seen? So here was what? 55 degrees. If here is 55 degrees, this line, you will see that this line crosses this line, and you know this is a vertically opposite angle, right? So if here is 100 degrees, it means that this side shows what? 100 degrees. Have you seen? Have you seen? And if here is 100 degrees, if here is 100 degrees, how are you going to get this side? How are you going to get this side? You subtract this 155. So if you subtract 155 from 180, 155 from 180, and then you'll be having what? 25 degrees. So it means the angle here will be what? 25 degrees. Now this is one way someone can solve it. And there's another way someone too can solve it. You can also solve it this way. You can also solve it this way. You can also solve it this way. You see, here is 110 degrees, right? I want us to solve it this way. We can turn the book. And then you got to realize that you can draw another chord here. When you draw a chord here, you will see that this one will be a triangle, right? This one is a triangle. See, let me erase this one, or let it be there. This one will be another chord, and then this is another triangle. Have you seen? This is an extension triangle that touches the what? The other side, or the circumference. And then they having the same chord. They are having the same chord for this smaller what? For this smaller what? I'm asking you a question. For this smaller triangle. So if this is having the same chord for this smaller triangle, when you have here, it means you'll be able to find where? The angle here. Do you understand? Let me take it for. We got 25 here. I think this one will not help us. We might get different answer. Okay, you let me. I think the simple way to solve it is this one. This one will be complex for you. And so let's stick to this one now. This one will be complex for you. So let's stick to this one. Let's move on to the next one. Can I erase it? Let me see. They had the same answer here. This one we've already done it. We did this one. And then let's move on to another one here. Let's try this question. I think we should continue with the properties rather. Let me add one property to it. So let's move on to another property rather before we jump into it. Another property that we have, it said equal chords. Now it says that, I'm reading it here, but after that I will explain it to you. It says that equal chords on arcs subtend the same angles at the circumference of the circle. Equal chords or arcs subtend the same angles at the circumference of the circle. So equal chords or arcs, what they are referring to is that, for instance, if you have a triangle, let me see, if you have a circle, if you have a big circle here, and then you have two triangles in, which are made up of chords. So two triangles in, this is one triangle, this is one triangle, and then another triangle is here. There's another triangle here. Let me take this one for instance. There's another triangle here. There's another triangle, and then if, let me take for instance, if here is A, here is B, right? And this length here is equal to this length here. This length here is equal to this length here, but you see this one is not drawn to scale, so let me draw it well. Maybe it should be close to it a bit, although it's not drawn to scale. So two triangles like this, and this length here is equal to this length here. That's what I mean. So if we have something like this, two chords in a circle. If you have two chords in a circle, whereby there is this length, let me say two triangles, and then two chords are equal. If two chords are equal, whereby I mean the down chords here, they are equal, we can say that the interior angles opposite to those chords or those equal chords. Do you understand? These angles, if they are opposite to these two equal chords. So if these angles are opposite to these equal chords, then we can say that then A and B2 are equal. Is that understandable? A and B2 are equal. So A is equal to B. A is equal to B. Okay. Okay, so let's move on to the other one. And you also realize, so this is, now we see that A is equal to B, right? Let's move on to another one. So this is another law. So when you have two triangles in a circle, whereby two chords of the triangle are equal, then you can say that those interior angles opposite to the chord is what? Equal. Is that understandable? Okay. Another property that we have to also talk about is this one. This one. When you have, it's similar to what I talked about. I think I can read it here. Equal chords or arcs subtend the same angles at the center of the circle. Whenever focus, let me explain it here. So you see, if you have a circle, and then if this is the center, and then this is a line, this straight line, and this one have two triangles in here. It has what? Two triangles in here. If it has two triangles in here, then two of the chords, you see this side and this side are equal. So it's similar to this one, but this one talks about triangles on diameter. So as I'm describing the thing, you can take notes. You can take note of it, and don't forget to subscribe to the channel, as well as you share to friends and then colleagues. Don't forget to subscribe to the channel and then share to friends and colleagues as well. So let's continue. As I was saying, this is a circle and then this is a diameter. If you have two triangles on the diameter, whereby they have one chord and each chord are equal, so this chord is equal to this chord, then we can say that this angle here, this angle here, which is, if here is A and here is B, you can say that they are also equal. You can say they are also what? Equal. You can say they are also equal. Okay, let's watch out for that one. Yeah, so these angles here will not be equal. The reason is that I wish I could get this one. I wish I can prove it for you to see. After that, you prove it with math set, you will realize everything. If this angle is equal, see, if this angle is equal, it means that this, you see this chord, the reason I'm saying that if this chord and this chord is equal, the opposite angles are equal. The reason why I'm saying is that because when you come here, this have different angle, this have different angle, but despite that the length is the same. The length is the same. I don't know how to explain it well, but if you have triangle, look at here. If you have two triangles, you see this length is the same as this length. This length is the same as what? This length. And then we have one. I don't know how to explain it well, but after that I will use a method to prove it for you. Okay. For the method to understand it very much as compared to this one. So let's move on to the next one. Now the next one, most people find it tricky. Most people find it tricky, but I will teach it in a simple way that you can able to remember it always, because this one is a bit confusing. I use something to always remember it. Here is how it is. So this is it. This is one circle, and then you have, so this is the circle, and then you see that you have a triangle in that circle. And when you have a triangle in that circle, you have a tangent attached to the circle. You have a tangent attached to the circle. So this is the tangent. You have a tangent. A tangent is a line that touches a circle. Oh shit. A tangent is a line that touches a circle at one point. Let me see if this is a tangent. Yes, so this is a tangent. This is a tangent. A tangent is a line that touches the circle at what? At one point. So here, for you to be able to know that it's a tangent, it touches a circle at what? One point. Do you understand? Now let's move on to this property. If you have this property, we are going to talk about the relationship between this side and then, the angle, that is the angle between the tangent and then the one of the side. The angle that is between the tangent and one of the side of the what? Of the triangle inside the circle. And then the relationship between the angles outside the triangle and then the angles inside the what? Triangle. Those are the relationship things we are coming to talk about. Those are the relationship things that we are coming to talk about. This one, it really confuses most of the students. And then most especially, you should note this. Whenever you are solving this kind of question, See, whenever you are solving this kind of question, you should consider only triangles that touches the what? That all the sides touches the what? The circle. If the side doesn't touch the circle, it means you can't apply this law. So you can write your personal note about it. When you are using this law, you should only consider, do what? Consider the triangle inside the circle, which all the three sides touches the what? Touches the circle. If the side doesn't touch the circle, it means it's not part of it. We can't use that law for it. Okay. So see, if you have a law like this, this is how you can apply this law. I want to read the book. I want to read what is in this book. After that, I will explain it, or I will teach you the way you can remember it. In the book, they will say that the angle between the chord, and then the tangent at the end of the chord. This one will make the thing confusing. I don't have to even read this one. Let's focus here. Let's focus at this side. So this is how you are going to do it. See, this is how you are going to do it. It's very simple. If this is angle E, pay attention. Teinati. Adeni teinati. Dina. Teinati. So here, what you do is that we are coming to find the relationship of the angle that is outside the triangle, and then the angle that is what? Inside the what? Triangle. This is what you will do. If this is the angle that you are considering, which one? The one I've named E. If that one is the one you are considering, you will start counting this line. You are counting 3 lines. You are counting what? How many lines? 3 lines. So this is the angle. So this is the first line. Have you seen? One of the side is the first line. This is the first line. After this first line, you don't have to move to anywhere. So this is first line. You have to come to the point back. So this is the first line. Then the next line is this. Then you come back. Then where is the next line? The next one is here, right? So you will subtend 3 lines. 1, 2, and then what? 3. Now the last one, the third one, any angle that falls between that line that you're talking about and then the side that also meets at the, at the circumference, is equal to the angle here. Mama Kaneta, do you understand? Mama can fancy say be kafan or tape na say fancy over it. Asum part at here. It's a must that this angle as I been the back 3 lines. You count 3 lines. This is 1, 2, 3. Then the angle on the what? On the circle, on the line, the third line is equal to the angle here. So this is 1, 2, and what? 3. So it means that here is what? E. Atasa. Do you understand? This is how you count it. Here is E. Let me know in the comment section whether you understand it or not. Let me know in the comment section whether you understand it or not. So if the angle 2 is here, come and show me the relationship. The next angle, where it will be. Let's go. It will be where? 1, 2, not 3. Have you seen 1, then 2, 3? So I told you that you should go back. So wait, come back to the vertex, the point 1. So it will be 1. Here is 1. This is 2, and then this is what? 3. So it means if here is A, then it means that here is also going to be what? A. Here is also going to be A. Is that understandable? Is that understandable? Uh-huh. That's all. The next question. The next property rather. And I told you that with this property, it's only if the triangle inside the circle touches all let me say the side of it, or the vectors touches all the circumference. Yes, it's only if it touches all the circumference. If it doesn't touch the circumference, it's not part. Okay, so the next one, let's go. The next one. Should I continue? Okay, so the next property, we are done with this property. The next property, this one I've taught you already, Bia. Yes. I think they are similar. They are similar. What do you say? They are similar. So you see that last time I taught you that when you have a quadrilateral inside a circle, so when you have this quadrilateral, if you have four-sided figure inside the circle like this, four-sided figure like this, even inside the circle, and then maybe we have here A, here B, here C, here D. The sum of it is equal to what? 1, right? So the next one is that the one I'm coming to talk about is a quadrilateral. So you can be also be given this. That's what they are saying here. So if you have a point here, and then you have this one, you say this triangle, another one. Then you have this one, everything. You have this triangle. Then you have this triangle too. You have this triangle too. You realize that these are similar triangles, right? They will, this another triangle too. So you see that this one, for instance, this is a triangle, this is a triangle, but when you look at them well, they are also quadrilaterals, right? In other words, that if here is A and here is B, the sum of them two are equal to what? 180. That's what the eighth law or property is about. So now we are done with circle theorem. That's all. You don't understand this one? Which one? This line now. No, the line coordinate. I'm saying that if they are triangles, two triangles, so this is a chord, this is a chord, and then we have triangle here, triangle here. But this is talking about the mainly triangles, but it's still a quadrilateral because do you understand what I'm talking about now? So here you see that this is A, this is B, and then since it's a let me say, since this is a triangle, this is a triangle, but Yakabuma still a quadrilateral. They are four sides, and since they are four sides, you can say the sum of them is equal to what? 180 degrees, and that is it. The sum of it is equal to 180 degrees. Yes, that's the case. Then it means that sum of this place and then this place is equal to 180. That's it. That's it. That's it. Okay, so let's continue. We are coming to solve more questions on circuit theory. I think we should go out for break and come back. When you come back, then we solve more questions under it. It's just 5 minutes break, so stay tuned. We will come back right now. Bye bye. Don't forget to Hello, don't forget to subscribe or share it to friends. Don't forget to share it to friends. Share it to friends so that you can join us. Bye bye. Peace out.